What's up, my peoples? We're looking at the 8.2 overview, and we're going to be looking at the special triangles here. Some of you would like to refer to this as a hack to the OG Pythagorean theorem because these two methods are really quick to kind of figure out answers without using the Pythagorean theorem. And in this first problem, we're looking at a 45 degree, 45 degree, 90 degree triangle. And what that states is that the legs, since they're equal to each other, the hypotenuse must be that side length times root 2. It's just that easy. Or you could simply use a squared plus b squared equals c squared, and you'll come to that same conclusion. So you can always use Pythagorean theorem. This is just a nice quick way to find a solution. So since we are given that the side length is 12, I know the hypotenuse is simply 12 root 2. It's it. It's over. It's done. We're moving on. Same thing is happening here, except instead of being given the leg length or the side length, we're given the hypotenuse. So all we do there is simply divide by the square root of 2, and then we have to do a little bit of rationalizing here, which ends up with 4 root 2. Or simply we just take half of this times root 2. So those are the two instances where we'll be using the perfect triangle when we're dealing with sides of 40 or angle lengths of 45 degrees and 90 degrees. Moving on to 13. More of the same here. We are given a side length of 6, which means all side lengths are 6. So that was done. And then my hypotenuse is simply that same side length times root 2. Done. It's over. Moving on, people. Now we're looking at 14. We have a beautiful looking plate. It's of course is a square, and we have some chopsticks that are 22 centimeters long. We want those to fit perfectly across the diagonal, which simply means we divide that by 2. But since it does not want an exact answer, we just simply put 22 divided by root 2 in our calculator to come up with 15.6. And that is the conclusion to 45, 90 degrees. And we're moving on to another special triangle in which has 30 degrees, 60 degrees. So opposite of the 30 degrees is this side, and which is called x. Then opposite of 60 degrees, the other leg is simply that same value of x times root 3. And then our hypotenuse in blue is simply 2 times the value of that same x. So in the given triangle that we're looking at here for number 15, I'm given that the hypotenuse is 12. So I simply set 12 or 2x equal to 12. I get x is 6. And since I know x is 6, then I can figure out what is y. That is simply my value of x times root 3. And we're done. Moving on to 16. Still looking at these 30, 60, 90 degree triangles, we have a nice little escalator happening here. Since we know that 30 degrees is here and this is our x, we simply plug that in here and multiply times 2 to find the hypotenuse of 52. And on to our final problem in looking at these special triangles. We simply break it up a little bit and look at them individually. So if we break up this first part of this larger triangle, we have a 45, 45, 90 degree. And that tells me that my side x has to be 7. Since I know the hypotenuse is 7 root 2, I simply just take what I need, which is the 7. So I get 2 answers from there. I get my a is 7 and my c is 7. So now going over to here, I know that this a is now 7. And so that 7 now correlates to the 30 degrees in this other triangle. So if I know this is 7, for B, I simply multiply that times 2 to get 14. Done there. And D is the one that is opposite of 60 degrees. So it is the one that is x times rad 3. And I simply replace the x with what I know it is, which is 7. And we are done.